So now let's move towards few examples. Okay, these examples are purely based on this concepts and shortcuts that we learned in last few lectures. So now first example is very simple, that energy of xt signal is E, then what is the energy of signal x2t in terms of E? Okay, and clearly it is E by 2 because it is E by mode A, and here A is 2, so we will get the same. Now this question is homework for you. Okay, so do solve it and post it in the comment box. So x of here u of t, x of t is given by 4 times u of t minus u of t minus 4. Okay, that is, it is being scaled by 4. Okay, so I am giving you the hint. The hint is use shortcut for rectangular pulse. Okay, so indirectly I told you that this is nothing but rectangular pulse. So do comment. Now let's move towards next example, that is x of t is given by r of t minus r of t minus 2. Okay, and the question is find E or P, that is either energy or power. So now the very first step is to decide whether signal is energy or power, and as always what we will do, we will plot the graph. So how do we plot the graph? So r of t is given like this. Okay, but at t equals to 2, what is happening? R of t will simply go like this, but at t equals to 2 we have negative sign. Okay, so the slope is negative now, and we are having the slope as -1, so it will shift it by 1. Okay, this and this will go up till infinite. So this is our resultant signal, like this ramp and then this constant. So what we have, we can say that our signal is extending from 0 to plus infinity, no doubt in that, but we can say that this is infinite duration signal but having finite magnitude, and this property is being satisfied by power signal. Okay, I hope you remember. So we can say that this is a power signal and we will find power for this. And as per our definition, we are not having periodic signals, so we will use a definition for non-periodic signals. So we will just integrate in one time period and we will find the power. So what we will do, this is limit t tends to infinity 1 by t. We will split the limits 0 to t. In 0 to t we are having this waveform and it is given by t, clear, and we are having square, and from 2 to t by 2, please note the limits, don't take it infinity, 2 to t by 2 we are having constant value. Okay, and the constant value is being given by, because this is 2 and this slope is 1 because it is r of t and r of t minus 2, clearly we are having 2 over here, so we have 2 square dt. I hope this point is clear. Let me explain you once again. This is r of t. Okay, it is going to infinite extent, but at t equals to 2 we are having one more signal which is being subtracted. Okay, r of t minus 2, so we have one more signal r of t minus 2, so which is being subtracted, so r of t is being subtracted from this signal. Okay, so the resultant signal will be like this, because r of t minus 2 will start from here and it will go like this, so and r of t will go like this. So if we subtract both this, then we have one constant value. So and this constant value is 2, because at t equals to 2 we have this 1, we can say this is 1, this 1 will indicate, this negative and positive sign will indicate that the slope is like this or like this. Okay, but this value, it indicates the actual value of slope, and over here it is 1, so we can say the slope is 1, and clearly if we have 2 over here, then and only then this slope is 1, because 2 by 2 y minus 0 upon x minus 0, that is 2 minus 0 upon 2 minus 0 is 1. So clearly we can say this value is 2. So this is 2 square dt. Now again we are having limit t tends to infinity only throughout, t cube by 3 integral 0 to 2 limits, and 4 is constant, and we can say t by 2 minus 2. I substitute the limit because integration is t, so it is t by 2 minus t. Now substituting this we will get 8 by 3, and this we will get 2t minus 8, clear, and 1 by t is outside. So 1 by t will be multiplied with this, and 1 by t will be multiplied with this, and 1 by t multiplied by this will be cancelled. So we are left with only 2 because we are having limit as t tending to infinite. So it will make this term and this term along with t as 0. So we are left with 2t by t, that is 2. Okay, so this is our answer of power. Okay, so that's all about this example. Now let me move towards another important point, root mean square. All of you are familiar with this term. You can go through your network analysis books, okay, to refer this. You can write it as root mean square, clear. So if we have mean square, clearly we can say that, first of all let me write root mean square equals to under root of power. Okay, because what we are doing in power, as per the definition, this is mean. Okay, xt by t in one time interval is mean, but we are taking square, so it is means square, means this is mean square. So mean square is power, so we can say root mean square is under root of power, clear. So this is very helpful in some of the objective questions in which they are providing RMS value and saying that find power of the signal. So this is the small but important point. So let us take one example. Now after this example we will conclude for power signals also, which we concluded for energy signals, that is time reversal, time what is whether the power is dependent on this time reversal, amplitude reversal, and so on. Okay, so after this example we will conclude the same. Now let's move towards example a cos omega not t plus phi, or you can say theta, and it is x of t, some signal, and our task is to find power. So we know for sinusoidal signal RMS value is given by maximum value by root 2, and we know that mean square value is power. So squaring both the sides will give us mean square value. So we will just do square. Okay, and this is the power of this signal, clear. And you can find this RMS value as a by root 2. Let me show you the proof that how we are getting this RMS value as a by root 2 for sinusoidal signals. Okay, so what we will do, we will do first square, then we will find mean, and at the last we will take root, clear. So first of all let us do square and mean, okay, and then whatever the result we will take root of the same. So first of all let me take the square of the signal. I am considering just omega t only, neglecting this theta. Okay, then what I am doing, mean, that is in one time interval. Okay, I am taking the mean, it is summing all this and taking the mean by dividing it by time interval, clear. So and obviously a square will appear outside because this is a cos square, a cos omega naught t. So squaring will give a square, so a square is appearing outside in multiplication. Now this a square by t is as it is, we can write cos square t as 1 plus cos 2 omega naught t, clear, by 2 dt, and integration is still left from minus t by 2 to plus t by 2. So it is a square by t, okay, let me show you, 8 square by t integration minus t by 2 to t by 2, 1 by 2 dt, and half integration minus t by 2 to t by 2 cos twice omega naught t dt, and we can clearly say this is 0 because integrating cos along its time period will give 0, and this whole is in multiplication with a square by t, and this term is 0, so we are left with this, and this 1 by 2 is taken outside, let's say, then we have integration dt as t, and substituting the limit we get t by 2 minus t by 2, that is t by 2 plus t by 2, and it is t, so this t and t will get cancelled and we get a square by 2, and this is mean square value. At the end we have to take root, so our taking square root will give a by root 2, and it is nothing but our answer, clear, RMS value. And so power is nothing but mean square value, so we can say this is a square by 2 is the power for this signal. So now let us conclude that power calculations, note that this is only valid for power calculations is independent of time shifting, because shifting in time doesn't make changes in any time period, okay, and in formula of power we have fundamental time period. So time shifting, then time scaling, because over here we are having omega naught t, okay, cos omega naught t is our question, but it is not reflected, the only reflected thing is amplitude, which is a, okay, it is maximum value, okay. So it is also independent of time scaling and also amplitude reversal, because our power is a square by 2, so if we take amplitude reversal also, the square of negative value is positive only, so we can say it is also independent of amplitude reversal, okay. So it just depends on amplitude scaling, so if we scale some signal by its amplitude, then and only then our power will change. So do compare both these things, okay. Our energy will be dependent on time scaling, okay, it is reduced by factor of a, the factor by which it is being scaled, our time domain signal is being scaled. So that's all about this power. Thank you.